So guys, in organic chemistry, we were dealing with properties of alcohols. We have discussed acidic nature of alcohols. We have shown that alcohols are weak acids and the reactions of alcohols because of their acidic nature when we broke down OH bond. Now see, one thing I have not told over there, factors affecting acidic nature of alcohols. That's if plus I effect is there, if minus plus M effect is there, what happened? That thing I will discuss with phenols. Now see, we have second type of reactions of alcohols. These are reactions because of reactions involving cleavage of CO bond. Reactions involving cleavage of CO bond. Now I am going to break this bond. Why? Because this is also pole. Now we'll see what type of reactions will arise over here. Now see what type of reactions will arise over here when we break down this type of bond. Which type of bond? CO bond. If I break CO bond in alcohols, let us take alcohol. हम यहाँ पे एक अल्कोहल मॉलिक्यूल को लेंगे और CO बॉन्ड को ब्रेक करेंगे. कहाँ किस तरफ ये बॉन्ड ब्रेक होगा? ये बॉन्ड तो ऑक्सीजन की तरफ ब्रेक होगा because oxygen is more electronegative. Now break this bond, we get carbocation. Carbocation means electrophile. In these reactions, alcohols will act as electrophile, means it will be attacked by nucleophile. I think we have discussed these reactions I have discussed in haloalkanes. That's like this RCH2OH. I have treated it over there with PCl3, PBr3, PCl5, SOCl2 with HCl and ZnCl2. These were the reactions which I discussed over there. Now this was Darzin's reaction. This was our Lucas test. We discussed mechanism of these reactions, and this is PBr3. I will discuss here only PBr3 because I have not discussed over there mechanism of PBr3. For other reactions you watch that video, that is preparation of haloalkanes from alcohols. In all these cases substitution reaction takes place, but the product we are getting RCH2Cl. In all the cases the product is same. Now the only factor we have to decide over there is which undergoes SN1 and which one undergoes SN2. Detailed explanation of this lies in that lecture. Please do watch that lecture. You will get this type of reaction involving cleavage of OH bond. You will get Lucas test over there. You will get Darzin's reaction over there. You will get reaction with PCl5 over there. You will get reaction with PCl3 over there. Not PBr3. Let us discuss reaction with PBr3, which I have not discussed over there. The mechanism is same like that of PCl3. I will take alcohol RCH2OH. I will treat this alcohol with PBr3, phosphorus tribromide. This is our PBr3. Now see what happens. There is a lone pair of electron on oxygen atom. This lone pair attacks this phosphorus atom and bromine leaves. If it attacks over there, what we get? RCH2 single bond O single bond H. This is this hydrogen. Oxygen is attached to phosphorus, and to this phosphorus we have two bromine atoms attached over there. Positive charge will be created because lone pair has attacked. Now see what happens. In the next step, what happens? A bond is formed between we have lost Br negative. That Br negative attacks this hydrogen atom. We get HBr. Therefore, we get PR, CH2, single bond O, single bond P, Br and Br. Now see what happens. This bond breaks towards this side. It will result in the formation of P double bond O, the stronger bonds, very strong bond. The formation of this very strong bond, it is driving force for this reaction, driving force. Therefore, this becomes positively charged. Bromine negative attacks over here. We get RCH2Br. This is the mechanism of the reaction. The driving force of this reaction is P double bond O. Actually, this is retrosynthetic reaction. This whole reaction takes place in one step. Retrosynthetic reactions are those which take place only in one step. Now one more type of, you can watch all these reactions which I have mentioned over here in my lecture, that is preparation of haloalkanes from alcohols. That's very important. If you watch over there, please do watch and then come to this lecture. Now let us take one more reaction of alcohols, that is dehydration of alcohols. This is very important from board as well as competitive exam point of view. Dehydration of alcohols. Dehydration of alcohols. What does dehydration mean? It means loss of water. Now dehydration of alcohols is acid catalyzed reaction. It is acid catalyzed reaction. Acid acts as a catalyst. It is acid catalyzed reaction. The acid is usually used over here are H2SO4 and H3PO4. We cannot use acids over here HX, one is HCl, HBr. We cannot use these acids over here. Why? There are reasons. We will discuss those reasons as well. HX we can't use, HCl we can't use, HBr we can't use. We use H2SO4 and H3PO4. Now dehydration of alcohols means loss of water. We will take alcohol CH3, CH2 and this is OH. Now we have to carry out dehydration of alcohols. Dehydration means loss of water. Dehydration is carried out in presence of acid H2SO4 or H3PO4. Now what happens? Loss of water takes place. We will first write product and then we will discuss mechanism of the reaction. It results in the formation of alkene. Now see how alkene is formed. What is the mechanism of the reaction? Let us discuss mechanism of this reaction. Mechanism. The first step involves Step first involves this ionization of the acid H2SO4. It dissociates to give H positive ions plus HSO4 negative ions. This is step first. This H positive ion, it acts as a catalyst. In the second step, what happens? In the step second, what happens? We take our alcohol RCH2OH. We treat it with H positive ion. This H positive ion has been obtained over here. It will be attacked by lone pair of electrons on oxygen atom, because OH is not a very good leaving group. OH is a poor leaving group. Therefore, to make it a good leaving group, we have to protonate it. The aim of using this acid is to protonate alcohol to make it a good leaving group. OH is a poor leaving group. OH is a poor leaving group. Therefore, to make it good leaving group, LG leaving group, we have to protonate it. We have to protonate it. Now protonate this oxygen atom, we get CH3, CH2, O, H and H. This is positive charge. Now oxygen becomes electron deficient. We can break this bond now towards oxygen atom. We will get carbocation. Therefore, step third will be loss of water has taken place. Dehydration has occurred. Step third will be from this carbocation. I will write it like this: CH3. I will write CH2H single bond CH2 positive. Now step third will be loss of H positive. This H positive can be lost by this HSO4 negative, because it's a catalyst. It converts back this H positive ion into H2SO4. Now when this bond is formed, when this bond is broken down, we get a double bond over here. This is a type of, what type of then reaction? It's elimination reaction. This is how dehydration of alcohols takes place. Means hydrogen is lost from which carbon atom? This is the functional group OH. To this functional group, the carbon which is attached, it's called alpha carbon. And next carbon which is attached to alpha carbon, it's called beta carbon atom. Hydrogen has been removed from the beta carbon atom. Therefore, this type of reaction is called beta elimination reaction. It's called beta elimination reaction. Why? Because hydrogen has been removed from beta carbon atom. That's why it's called beta elimination reaction. Or we can number this carbon as 1 and number this carbon as 2. From one carbon atom we remove OH, and from second carbon atom we remove hydrogen. It's called 1-2 elimination. It's also called 1-2 elimination. Beta example is an example of beta elimination is an example of 1-2 elimination reaction. Now see, in the overall process we regenerate back H2SO4. Now a species which initiates which does not take part, which only enhances the rate of the reaction and is removed back at the end of the reaction, that's a catalyst. That's why this H2SO4 is catalyst. Now what we have read over in this section, dehydration of alcohols is a two-step process. First, protonation of alcohol takes place, then removal of hydrogen atom from beta carbon atom, resulting in the formation of alkene. That's why it's called beta elimination or 1-2 elimination reaction. Now why we can't bring this reaction with HCl? Had we taken HCl over there, we would have got H positive and Cl negative. Since Cl negative is a small species can substitute over here, we can get then the substituted product. That's why we prevent using HCl, HBr, because in that case we will get substituted product. HSO4 is a bulkier molecule. H3PO4 is a bulkier molecule that does not undergo substitution, that likes to abstract hydrogen atom rather than to undergo substitution. This is the reason why we do not use HCl and HBr or small acids. That's why we use bulkier acids. That's why in your text it is mentioned dehydration is carried out in presence of H2SO4 and or H3PO4. It is specifically mentioned over here. Otherwise, it would have been mentioned over there that dehydration is carried out in presence of any acid. Because the problem with other acids is they might undergo substitution reaction. Now let us solve a question on this dehydration. This reaction is carried out in presence of H3PO4. Now what type of reaction will be? It will be dehydration reaction. We will determine its mechanism in single step. Now this takes this leaves. If it leaves, it becomes del plus. Hydrogen will be extracted from the beta hydrogen atom. Therefore this is hydrogen atom, we get the product. This is one step reaction mechanism, how you can determine mechanism in only one step. This is one step. First, protonation, loss of OH2 group, formation of positive charge, loss of beta hydrogen atom, formation of double bond. Only in step 1 I have shown all the mechanism. Now let us take one more example. I will treat it with H2SO4. H2SO4 means H positive obtained from H2SO4. Now what happens? This takes over this, loss of OH2 plus, this is del plus, formation of double bond. Now what happens if we have more than one beta hydrogen is available? That is the question. If we have more than one beta hydrogen is available, what happens then? Now let us check what happens if we have more than one beta hydrogen is available. Which one will be removed? Now see, let us take the case. This is our C. And this is our H. This is our H. This is C. This is CH2H. And this is H. This is OH. Now see, this is alpha carbon atom. This is beta carbon. This is beta carbon. Now see, in this case what happens? First protonation of this takes place. After protonation, this can be lost. We get a carbocation on alpha carbon atom. We get a carbocation on alpha carbon atom. We get a carbocation on alpha carbon atom. This is positive charge and this is CH2H. Now there are two possible ways. I can remove this beta hydrogen atom or I can remove this beta hydrogen atom. Now which beta hydrogen atom will be eliminated? It depends upon the nature of the base and it depends upon the stability of the product. If the base is very bulky, means TBuO minus, this is a very bulky base. then this bulky base cannot approach this side. It abstracts terminal proton, we get less substituted product. If the base is small like HSO4 negative, it can abstract this and we get this type of product. Means we can get these two types of products. If base abstracts this proton, then we get a double bond over here. If base abstracts proton, then we get a double bond over here. Now see, if base abstracts proton, then we get a double bond over here. This will be CH, double bond C. This is hydrogen and this is CH3. Now if our base abstracts this proton, then we get a double bond over here. Other product we are going to get will be like this. C, H, H, single bond C, H, double bond CH2. Now this product is more substituted product because this sp2 hybridized carbon has one alkyl group over here and this does not have. This is more substituted product. More substituted product. And this is less substituted product. Now which one will be major product? That will be decided by base. If base is small, then more substituted product is formed, and if base is large, then less substituted product is formed. There are two rules actually. One is called Hofmann elimination, other is called Sedzoff's elimination. Hofmann's elimination gives less substituted product and Sedzoff's elimination gives more substituted product. Hofmann's elimination gives less substituted product and Sedzoff's elimination gives more substituted product. This is Sedzoff's product, this is Hofmann's product. Hofmann's product can be formed in case of large bases, and this is, I have already explained you in my class. I have told you there what are the conditions under which Hofmann's product will be formed. This is Sedzoff's product. Usually Sedzoff's product is more substituted product. This will be a major product. Now I think you got it. These were certain reactions. Now the most important reactions of alcohols are, they are oxidation reactions. They are very important for any exam. They are very important. Why? Because there we have number of oxidizing agents. How do they work? We will discuss that in the next part. That will be very important. Now that is end for today. I hope you like it. If you like, then press the like button and subscribe the channel. Thanks for watching.